So, next speaker coming on stage is running a family business, an electronics company developing control systems for special purpose machines and sensor solutions. She says, I've never done that before, so I'm absolutely sure I can do it. You all know that Pippi Longstocking's quote, but she is living on that quote because taking over a company from your dad with high expectations puts a lot of pressure on you. Being a mom of 2 kids is another pressure, but she's handling and maneuvering through this. She used to work in the healthcare sector, and now, since she's working in that family business for 10 years, she's the managing director and is handling this pressure very well. She shapes innovations at the intersection of technology, people, and the future across a wide range of industries. Please welcome, with a big round of applause, the managing director of CESYS in Germany, Herzogenaurach, from the neighborhood, Julia Gelsebach.
Thank you very much. Do I have to start the presentation? No. Here. Okay. Have you ever spilled a hot cup of coffee and your hand retreats even before you think? That instant reaction, that moment, that's reflex. Reflexes are what makes us react instantly, even before we think. Now imagine robots had that too. Not pre-programmed processes, but instant reactions to what happens around them. That's a starting point where everything starts I want to talk about today. I want to give a vision, maybe another point of view. Even though robots have become faster, smarter, and more precise over the years, their control systems are often based on concepts from the 80s. Meanwhile, product life cycles shrink. That demands extreme flexibility in manufacturers. That means factories have to adapt faster than ever. But reprogramming is expensive and often very slow, depends on the company. This mismatch is what's holding us back. Collaborative robots and human-machine interaction require instant adjustments. No real-time adjustments means higher cost and inefficiencies. Furthermore, rigid systems create downtime and production bottlenecks. It's like running a Formula 1 race with a car from the 80s. No matter how skilled the driver is, you can't just keep up. In Formula 1, milliseconds decide between victory and failure. Every lap, cars process data from hundreds of sensors. They detect grip, temperature, fuel, speed in real time. And they optimize themselves and their performance also in real time during the race. Now imagine robots doing the same, reacting instantly to what happens around them, not following a fixed program, but continuously adapting. That's the performance level industrial robots need to go. We have built robots to be more precise, to be predictable, to be safe. But maybe it's time they come a little bit more alive. Of course, not in a science fiction sense, but in a sense of responsiveness. Why are classical control systems are not enough? Traditional controllers like PLCs or CPUs work step by step. They wait for commands and they process in sequence. That's fine for static, predictable processes, but not for a modern environment. FPGAs, on the other hand, process data in microseconds. They react directly in hardware. That means there's no waiting and no operating system delay. They enable true real-time response. Definitely the foundation of real responsiveness and robotic reflexes. Today, we are already first steps. It's not a new thing. High-speed pick-and-place robots using FPGA-based image processing are state-of-the-art. Adaptive grippers, we have had that before, that just adjust to different shapes. Or AI-assisted pattern recognition that avoids errors even before they happen. And yes, there are high-speed robotic arms with special cameras that even grip falling objects. But these are only early glimpses of what's possible when hardware speed meets intelligent control. The next step is coming. We are seeing it already on the horizon. Flexible assembly lines with self-adjusting robots, autonomous transport systems reacting instantly to obstacles, and collaborative robots that move intuitively with humans. I've talked to a friend of mine who sells medical robots. I thought they should be cleverer than they already are, so this is really a next step. These systems won't follow pre-programmed rules. They learn and respond autonomously in real time. We are moving from a programmed automation to adaptive behavior. And here is where it all comes together. Let's combine sensors, FPGA, and AI, because that's where it's getting exciting. Real-time sensors act as the sensors and detect, for example, damages in microseconds. FPGAs execute reactions instantly without delay, like, say, the reflex arc, and AI learns and optimizes over the time, like our brain. Together, they form something like a nervous system. Machines that can sense, decide, and act almost instinctively. That's how robots will gain real responsiveness. And yet, most production floors look they did 20 years ago. It's not because technology isn't ready, it's because we aren't. Change isn't only a technical thing, it's a psychological one. So, why don't we see this everywhere yet? Most production systems are still built for rigidity, pre-planned and predictable processes. Controllers can't handle real-time computation, and companies hesitate to embrace disruptive change. It's not about technology, it's about mindset, and it's about a big part for risk tolerance. But as flexibility becomes a survival factor, that hesitation will have to fade. Let's take a hint from nature. A swarm of birds or bees has no central command, yet it moves in perfect coordination. Each member reacts to its neighbor in microseconds. And that's one of my most favorite facts. It's the same with octopuses. They have a brain in each arm, yet the animal reacts as a whole. That's the principle robotics should follow. Decentralized, flexible, and responsive. Not centrally controlled, not rigid. FPGAs make this kind of contributed intelligence possible. Each unit reacting locally, but in perfect harmony with the rest. The next evolutionary stage begins now. The technology is already here. FPGAs are available and proven, and AI is coming. What we need now is the courage to rethink automation. Real-time systems are the key to flexible manufacturing. So the question isn't whether robots need reflexes, it's who will be the first to benefit from it. We spent decades teaching robots to follow instructions. The next decade will be about teaching them to respond. Not just to data, but to the unexpected. And maybe, just maybe, it's where technology becomes a bit more human. So let's explore together how real-time intelligence can redefine automation means. Because the future isn't about just faster robots, it's about giving machines the ability to feel, decide, and act just like us.
Thank you so much. I love the Formula One comparison, and I don't think I was the only one here in the room, yeah? Especially when we talk about reflexes, especially when the lights go out.
Yeah.
I'm like, wow. Do we have any questions in the audience for Julia? There's one over here, yes. Gunesh, can you... It's there. The microphone should be at the back somewhere. Perfect, thank you.
I have a problem for you. Distributed control is not that simple. You have a big problem, just look at traffic. There is a controller in each car. It's sub-optimizing every day and every second. How do you handle this?
Yes, this is just a vision. And it is hard, and it is, for real, expensive. So you have to look where it's really needed. And of course, there's a lot of traffic. So these are problems that you have to handle, but this is just a vision where it could go if everything would be possible.
Okay. Do we have any more questions here in the audience? Doesn't look like it. Then I'd like to ask you one.
Yeah.
I mean, it's all quite impressive when machines and robots start making their own decisions, but how do we ensure, compliance, reliability, that aspect, to make sure we don't forget that?
Yeah, this is a crucial question, and you have to make sure that you know why decisions are taken and how these AI or machines are thinking. You can't just put AI somewhere in and say, okay, now do on your own. I think this is an AI problem in general. Yes, you have to find some rules to handle this, and at least to have the data the decisions are based on. Yes.
Okay. Well, thank you very much,
Thank you.
Julia. Big round of applause for Julia. And